Welcome to homework.
So for this question, we're basically asked to change the word descriptions into the actual written chemical formulas. So first we have zinc carbonate forming into zinc oxide and carbon dioxide. So we'll start out with zinc carbonate. So we have zinc, and then our carbonate here. So that's zinc carbonate, and it's forming, so it's being turned into, when it's heated, zinc oxide and carbon dioxide. And then if you look, it's balanced, right? We have 1 zinc on each side, 3 oxygens on each side, 1 carbon on each side. Then for the next question, when silicon dioxide is treated with hydrofluoric acid, it forms silicon tetrafluoride and water. So on the reactant side, right, we have silicon dioxide. So we have silicon dioxide. Di means 2, which means we have 2 oxygens. It's added to hydrofluoric acid. So acid, we always have hydrogen first. Fluoric is for fluorine. Those added together create silicon tetrafluoride. So silicon, the symbol is Si. Tetrafluoride, tetra means we have 4. Fluoride stands for fluorine, so it means we have 4 fluorines plus water, and then we know water is H2O. So now we need to balance this equation. So we have 1 silicon on each side, so we're good there. But we have 1 hydrogen on the left, 2 hydrogens on the right. And then we have 1 fluorine on the left, 4 fluorines on the right. So let's put a 4 here. So we'll have 4 fluorines on each side, but now we have 4 hydrogens on the left, 2 on the right. So we'll put a 2 here. Now we have 4 hydrogens on each side and 2 oxygens on each side. So now this equation is balanced. Now we'll go to question C. So we have sulfur dioxide reacting with water. So our 2 reactants are sulfur dioxide. The symbol for sulfur is S. And then dioxide. Oxide means oxygen. And then di means 2. So we have 2 oxygens. Reacts with water, so plus H2O, to form sulfurous acid. So acid, remember, we always have a hydrogen first. And then sulfurous is from sulfate, so it's actually H. Sulfurous acid is H2SO3. So now if you look, we have the same elements on each side, so it's balanced and we're good. Question D. We're just looking for the substance phosphorus trihydrate. So if you look up in the periodic table, the symbol for phosphorus is just P, and then trihydride. Hydride is for hydrogen, and then the prefix tri means 3, so we're going to have 3 hydrogens. So that is the symbol for phosphorus trihydrate or phosphine. Then for E, perchloric acid reacts with cadmium. So our 2 reactants are perchloric acid and cadmium, so they're going to be on the left-hand side of the equation. Perchloric acid, remember we have an acid, so we always have a hydrogen. And then perchlorate is ClO4. That's the polyatomic ion for perchlorate. So perchloric acid is going to be HClO4. Some of the polyatomic ions, you just kind of have to memorize their names. So the perchloric acid is going to react with cadmium, which if you look it up in the periodic table, the symbol for cadmium is Cd. And then those 2 react to form, which means our product, or the right-hand side of the equation, is cadmium to perchlorate. So it's going to be cadmium with the polyatomic ion perchlorate. Now, what that 2 means behind the cadmium is that means that cadmium is a 2+ ion, and then perchlorate has a -1 charge. So in order to figure out how much of each that we have, right, we do the cross thing. So the -1 means we have 1 cadmium, and the +2 cadmiums means we need 2 perchlorate ions. So this whole polyatomic ion, we're going to have 2 of them. Now we also have this hydrogen by itself over here. So we're going to add hydrogen. And hydrogen by itself is always a diatomic molecule, so it'll be +2. Here, let me erase some of this below here so we have it more clear. So now let's balance the equation. We have 2 hydrogens and 2 perchlorates on the right side and only 1 on the left side. So we'll add a 2 here. Now we have the same amount of each element on each side. Now for the last one, we're just asked to write the symbol for vanadium bromide. So vanadium, if you look at the periodic table, the symbol is V. And then bromide, right, is just bromine. Now to figure out how much we have of each, right, it's vanadium 2, which means that vanadium is going to be a 2+ ion. And then we know that bromine has a -1 charge. So then we cross over, right, we have a +2 charge. So we're going to have 2 bromines, and we have a -1 charge here, which means we have 1 vanadium. So now that means the anions balance out to have a neutral equation, right? Because we have vanadium with a 2+ charge, and now we have 2 bromines, each with a -1 charge. So now these 2 positives equal out the 2 negatives here, leaving us with a neutral compound.